So paper 1 core vocab. Today we're looking at the challenge of natural hazards, focusing on weather hazards and also a little bit on climate change at the end. So these are the words that you're going to find in your lessons that you're using frequently, but you'll also come across them in the exam, revision guides and the textbook. And the idea is that we need to use these words confidently and fluently in our exam answers. So the first word, global atmospheric circulation, looks quite daunting, but we can break it down. So global, we're talking about the movement of air around the world. Atmos means anything to do with air, and circulation is circulating or moving around the world. So it is the global system of winds that move from areas of high pressure to low pressure, so along a pressure gradient, which you'll learn about in science. And you can see the air circulating around in the diagram. So surface winds, these are just winds that occur on Earth's surface. When you feel the wind outside on the playground, that is a surface wind. It's just air moving from high pressure to low pressure. Pressure belts, so these are areas, horizontal areas that follow lines of latitude, characterized by either high pressure or low pressure. So for example, in deserts where it doesn't rain a lot, that's high pressure because the air is sinking. So all across the Earth, just north and south of the equator, we get bands of high pressure or pressure belts of high pressure. Alternatively, we can have bands of low pressure as well. So for example, in the UK, we lie on a low pressure belt where the air is rising, and that's why we get so much rain. So the greenhouse effect. The greenhouse effect is a natural system of gases in the atmosphere that trap heat and keep the Earth warm enough to sustain life. So it's a natural greenhouse effect. However, with all the human activity, so burning fossil fuels, but also releasing CO2 by deforestation, humans have enhanced that greenhouse effect or made it stronger. They've made that blanket of greenhouse gases thicker. So then we have an enhanced greenhouse effect, which leads to increased warming, too much warming, which we call global warming. Next, tropical storms. So they're called tropical storms because they are storms that only occur in tropical regions. So they'll only occur in seas where the temperature is 27 degrees Celsius. And they're very powerful pressure systems. The key thing that differentiates them is that they are much higher energy than normal storms, and they tend to spin, or sometimes called cyclones. The main one that we'll look at are hurricanes, which are generally tropical storms that occur in the west of the Atlantic Ocean and the east of the Pacific Ocean, basically around North and Central America and the Caribbean Sea. So in the center of a tropical storm is the eye. That is where the weather conditions are the calmest, so the lightest rain and the calmest of winds. And the reason for that is because the air is sinking. It's an area of high pressure. The eye wall, right next to the eye, is where we get the worst conditions. So torrential rainfall and high speed winds up to 200 miles per hour in the strongest categories of hurricanes. Around the edge of that area of high pressure, because they are an area of low pressure where the air is rising and forming cumulonimbus clouds. And then finally, rain bands. So these are the kind of swirling bits that you see around the edge of a hurricane. So fairly light wind and fairly low rainfall, still more than the eye, but less than the eye wall. Frequency. So frequency is the amount of times that something occurs. When we talk about the frequency of tropical storms, one of the main things that's driving the increased frequency, or tropical storms happening more often, is climate change. Because the Earth is warming, more of the sea is at that 27 degrees Celsius temperature, so we have increased frequency. Our tropical storms are happening more often. So weather hazard is an impact on people or property. So if a tropical storm was to happen in the middle of a desert where nobody lives, that's not a weather hazard because it's not affecting people or property. However, if Hurricane Katrina hit New Orleans, which it did, flooded people's homes and caused massive disruption and death, that is a weather hazard because it's harmed people or property. Social impacts, these are any issues that are going to impact people. Economic impacts, any issues that are going to affect the economy. So whether that's people's jobs or the national economy, GDP, or the government are going to have to spend a lot of money to repair after a weather hazard and rebuild. Those are economic impacts. And finally, environmental impacts. So nice example, flooding after a tropical storm. That's going to damage ecosystems. So the storm surge, Hurricane Katrina damaged lots of coastal ecosystems. Those are environmental impacts. Now we're going to move from weather hazards onto the topic of climate change. So all of this vocabulary links to climate change. So orbital changes, those are changes in the Earth's orbit or its movement around the sun. The main one of the Milankovitch cycles that we are going to look at, or you should focus on, is eccentricity. All that means is that sometimes the Earth's orbit is more circular, like you can see on this green dashed line, but at other times it's a little bit more elliptical or oval shaped, which you can see in the blue line. And that change in the Earth's orbit, its proximity or closeness to the sun and its radiation, mean that our global temperatures can be higher or lower by a very, very small amount, a few tenths of a degree. So generally, in the green dashed line, the less eccentric orbit, the Earth is warmer because it's a bit closer to that solar radiation. And on the more eccentric or the more oval shaped orbit, it's going to be a little bit cooler because it's slightly further away. Okay, solar output is the amount of energy released from the sun. So output, the amount of sunlight and energy that the sun is putting out. So sunspots, which you can see on this diagram here, but also solar flares, which are large amounts of radiation that can be released by the sun at random points. They can cause variations in solar output and global temperature. So a large solar flare, for example, can increase the Earth's temperature. Fossil fuels. So fossil fuels are really important in terms of climate change because they impact the amount of carbon dioxide that we are putting into the atmosphere and that enhanced greenhouse effect. So things like coal, oil, natural gas, which are finite resources that are formed over millions of years. That's why they're called fossil fuels. They're an important source of energy, but they also release a lot of carbon dioxide. Deforestation is the process of cutting down trees. Nice and simple. Deforestation releases carbon dioxide as trees are a massive carbon sink. Agriculture basically means farming. So whenever you see agriculture, think farming. Dual code yourself a little farmer if you need. When plants and livestock are cultivated either to eat or to sell. Adaptation is changing our lives so that we can keep our quality of life but still cope with the effects of climate change. So for example, in Indonesia, these people have built their houses on stilts, or they're known as kampungs, in order to combat or adapt to rising sea levels as a result of climate change. Mitigation, on the other hand, is stopping the root cause of climate change. So ultimately, that's removing or not putting carbon dioxide and greenhouse gases into the atmosphere. So for example, wind power is a way of producing energy without putting carbon dioxide into the atmosphere. So stopping the root cause of climate change. Another example of climate change mitigation is afforestation, or planting trees, because they remove carbon dioxide actively out of the environment. Alternative energy production, so anything that isn't fossil fuels and traditionally what we rely on, is finding new ways to create energy using renewable resources that won't run out. So things like wind power, solar energy, geothermal power, hydropower, all ways of creating electricity that are sustainable. They don't produce greenhouse gases, but they will also last for future generations. Carbon capture, sometimes called carbon sequestration, is the act of capturing carbon emissions, usually from a factory or a power plant, and then sequestering or drilling them, shooting them into the ground. What happens there is that it turns into rock, basically, rather than going into the atmosphere and adding to the enhanced greenhouse effect. Afforestation we've already mentioned, so deforestation, cutting down trees. Afforestation is planting trees as an example of mitigation, because they remove carbon dioxide from the atmosphere during photosynthesis. International agreements are agreements where two or more countries, it's usually most of the countries in the world, work together with common aims to reduce the impacts of climate change or the causes of climate change. They're an example of mitigation. The most recent example, or the best example, is the Paris Climate Agreement in 2015, where 196 countries ratified or signed to say that they were going to take actions necessary to keep that global warming no more than 2 degrees Celsius above pre-industrial levels. So trying to reduce the impact of all the CO2 that was released. Rising sea levels is an example of the effect of climate change. The sea rises everywhere, so the melting of polar ice caps and glaciers leads to more water being in the sea, rising sea levels, which cause flooding, which cause massive environmental, economic and social effects. So that's a quick run through of weather hazards and climate change vocab. Now that you've got a copy of all the definitions, either screenshot this and have a go at writing down what you can remember and filling the rest in after, or get a copy from your teacher. Brilliant.